The distance formula. Objective of this lesson, to find the distance between 2 points in the coordinate plane. Let's consider this example. You have points A and point B. Okay, point A has coordinates -2, 6. Point B has coordinates 5, 3. We want to find the distance between these 2 points. Okay, the problem is it does not lie on a horizontal or vertical line where we can simply subtract the x and y coordinates. So we need to find another method to use to be able to find the distance between those 2 points. Okay, fortunately, with A and B, we can create a right triangle. Okay, and when we create a right triangle, to form a right triangle using points A and B, we need to consider point C. Okay, point C will make this into a right triangle. And in order to find the distance B and the distance A, this is what we need to do. To be able to find distance B, we need to subtract the 2 y coordinates. It only makes sense. 6 minus 3 will give us distance B. Okay? In order to find side A, we need to subtract 5 minus -2. Though the x coordinates this time. To be able to find this length, we need to get this x coordinate and this x coordinate and get the difference, which is 7. Okay? So now we have a right triangle, and we can use the Pythagorean theorem to be able to find the distance of C. And this is our Pythagorean theorem, where again A is equal to 6 minus 3, which is 3, and side B is equal to 5 minus -2, which is 7. Okay, substituting the values, we now have 3 squared plus 7 squared equals C squared. Okay, so C squared equals 9 plus 49, or C squared equals 58. To solve for C, okay, we simply get the square root of C squared, and that with C equals radical 58. And what is radical 58? Let me bring that up. Okay, radical 58 is nothing more than radical 58 is equal to 7.615. So the value of C is 7.615. Okay, so using that, this is what we got, and there we go. Pythagorean theorem, substitute the values. Okay, 49 plus 9, okay, gives you radical 58, or 7.612, as an approximate value of C. The distance between points A and point B is approximately 7.62 units. Okay? And from what we did there, how were we able to find the value of C using the Pythagorean theorem? Okay? How do we get that to be able to derive the distance formula? Okay, and this is a short video of that.
How can we derive the distance formula? Well, let's say that we have 2 points on a coordinate plane, and we want to find the distance between those 2 points. We'll call that distance D. Now, how do we find the distance between these 2 points? Well, let's take a closer look at the 2 points. Let's give these 2 points ordered pairs. So here we'll need an x-coordinate. We'll make that x of 1. And here we'll make this x-coordinate x of 2. Then we'll have y's of y sub 1 and y sub 2. Now here, these variables represent values. We just don't know what they are. So we can simply use these variables to represent unknown values. So let's look again at this point. This point now has the ordered pair x sub 1 comma y sub 1. And this point is the ordered pair x sub 2 comma y sub 2. Great. But how do we find the distance between those 2 points? Well, let's think about this. Let's say that we take this line right here, and let's make it a part of something. Let's make it part of a triangle. And let's make it the hypotenuse of a right triangle. So, in step number 2, let's create a right triangle where that distance d is the hypotenuse. So from this point, we'll draw a horizontal side. And from this point, we'll draw a vertical side. And here we'll have our right angle. Now, the hypotenuse is this distance d. But we can also figure out the distance or length of each one of these other sides. To do that, take a look at this side. We need to find the distance between these 2 points. So, in order to find the length of that side, or the distance between those 2 points, we simply need to find the difference between the x-coordinates. So we can take x sub 2 minus x sub 1, and that will be the length of this side. That means to find the length of this side, we need to find the difference between our y-coordinates. So we take y sub 2 minus y sub 1. And now we have a length for each one of the sides. But how can we find a formula for d? Well, we are now working with a right triangle. And we know something about right triangles. If we have a right triangle, we can use the Pythagorean theorem to show the relationship between the sides of the triangle. So let's take a look at the Pythagorean theorem. To do this, we need a right triangle. So we draw a right triangle, and we'll label the sides A, B, and C. Now, the Pythagorean theorem states that if we have a right triangle, we can take each of the sides, square them, and add them together, and that's equal to the hypotenuse squared. In other words, we would have A squared plus B squared equal to C squared. Now, we're working with a right triangle, so we can apply the Pythagorean theorem to our right triangle. So let's do that. Except instead of A, B, and C, we'll need to plug in the lengths of each of our sides and the length of the hypotenuse. Here we know the length of this side to be x sub 2 minus x sub 1. Then the length of our other side is y sub 2 minus y sub 1. And our hypotenuse squared would be d squared, since d is the length of the hypotenuse. And now we have side squared plus side squared equals hypotenuse squared. And we have an equation that we can use to solve for d. To solve for d, we need to move that square to the other side. That means we need to perform the opposite operation. And the opposite of squaring is taking the square root. So we take the square root of both sides of our equation. Here, if we square something and then take the square root, the square and the square root cancel each other out, and we just have that value, d. So d is equal to all of this. The square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And look, this is the distance formula. We have just derived the distance formula. Here, we were able to use our knowledge of right triangles and the Pythagorean theorem to derive the distance formula.
And that's about all she said. Okay, so she can explain it better than I can. So that's how you derive the distance formula, which brings us to the distance formula. The distance formula is d equals radical x2 minus x1 squared plus y2 minus y1 squared. Okay, follow this formula, you'll never go wrong. Okay, let's look at this example. If you have coordinates 3, 5, and 6, 4, how do you find the distance between those 2 points? Okay, and this is how you find the distance between the 2 points of 3, 5, and 6, 4. The first thing you need to do is you need to label your points. When I mean label, you get 3, 5. Okay, point 3, 5. Put this up first. And 6, 4. and label this x1, y1, x2, y2. That's the first thing you do. After labeling your points, okay, write down the formula. Distance equals radical x2 minus x1 squared plus y2 minus y1 squared. Okay, and this is simply substitute. This now becomes 6 minus 3 squared plus 4 minus 5 squared. Okay, you end up with 3 squared plus negative 1 squared. If you notice, whenever you square a number, you end up with a positive number. So you end up with 9 plus 1, which is radical 10. Okay? Now that is the distance between those 2 points, which is radical 10. And radical 10 is approximately equal to 3.16 units. That is now the distance between points point 0.35 and 0.64. Okay, let's consider the next example. Let's say you have a triangle and you want to determine if triangle ABC with vertices 3, 4, negative 3, 4, this is negative 3, 4, okay, and 5, 2, right here, and negative 1, negative 5, is an isosceles triangle. Now, the thing to remember is this. You need to first determine, or let me go back. It is being assumed in this problem that you know what an isosceles triangle is. And let's review what an isosceles triangle is. A triangle is isosceles if at least 2 sides are congruent. So that means you need to find the measure of AB, BC, and AC. If 2 sides are congruent, then you have an isosceles triangle. Let's consider side AB. Side AB is this side, 5, 2, and negative 1, negative 5. Okay? If you consider the formula for the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, get its radical. Okay, you end up with 5 minus negative 3. 5 minus negative 3 right here. Okay, and 2 minus 4 right there. Okay, sorry, we're considering these 2 points. Okay, these 2 points and not point C. So you now have 8 squared minus negative 2 squared, or radical 68. Okay, that is the measure of side AB. Now, do we need to find the decimal value? You can if you want, but you can leave it as that because we just want to find if 2 sides are congruent. So in B, if you notice, do the same thing. BC, get this point and this point right there, this point and this point now. Okay, those 2 points now are correct. You now have negative 6 squared plus negative 7 squared, or radical 85. Okay, one last side, which is side AC. Side AC is you want to find the distance between A, this point, and point C. Okay, again, using the distance formula, this becomes negative 1 minus negative 3, negative 5 minus 4 squared, and you end up with radical 85. If you notice, this is radical 85, that is radical 85. Those 2 sides are congruent, therefore we have an isosceles triangle. Okay, so that's how you determine if these if this is an isosceles triangle or not. And let's look at the last example. We want to find the value of the distance between the points with coordinates negative 3, negative 2, a negative 5, and the distance between those 2 points is 5 units. What we want to know is that we want to find out the x-coordinate value of A. Okay, how do we do that? Okay, first things first. First off, write down the formula for distance. Okay, distance formula again is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, now does it matter what is what you label x1, y1, x2, y2 right now? The answer is no. It doesn't matter which you label x1, y1, x2, y2. This can be your x1, y1, and this can be your x1, y1 for as long as you are consistent with your labeling. So, in this case, we now have, following the distance formula, okay, x2 would be A, x1 would be negative 3, and we want to square that, plus y2, which is negative 5, minus negative 2. Again, we want to square that using the distance formula. So you now have radical, okay, A plus 3 squared plus negative 3 squared. Okay? And from there, using special products, this becomes a perfect square. A plus 3 squared is nothing more than A squared plus 6A plus 9. And negative 3 squared is 9. Okay? Simplifying that expression, okay, you now have A squared plus 6A plus 18. Okay? If you notice, A squared plus 6A plus 18, okay, is a trinomial. And we forgot to substitute the value. D is 5 according to the problem. The distance between them is 5 units. So from there, okay, we square both sides of the, okay, let me go back there. Okay, we square both sides. So you have 5 squared in this case. Okay, 5 squared equals radical A squared plus 6A plus 18 squared. We square both sides. After squaring both sides, end up with 25, and the radical sign goes away. You have now A squared plus 6A plus 18. Okay? From there, we subtract 25 to both sides so that we can equate it to 0. If we subtract 25 to both sides, you end up with 0 and A squared plus 6A minus 7. Okay? Using the zero product property and the power of x, what do we get? Okay? You have negative 7 here and 6. Okay? And you now have 7 and negative 1 as your factors. So 0 equals A plus 7 times A minus 1. Using zero product property, A is equal to negative 7 and A is equal to 1. So the value of A would be negative 7 or 1. Okay? Again, lesson's done, so you need to write a summary responding to the objective of the lesson and write a question you might want to ask in class about this lesson. Okay? Thank you.